An equation with one or more radicals containing a variable is called a radical equation. To solve a radical equation, you should do the following. First, isolate the radical. If an equation has more than one radical, choose one of the radicals to isolate. Once you've done that, raise each side of the equation to the power equal to the index of the radical. And finally, solve that resulting equation. Repeat steps 1 and 2 as necessary. It should be noted that if the index is odd, you do not need to check to see if there are any extraneous solutions. The solutions that are found, if you have done it correctly, are the answers. No need to check. Only if the index is even do you need to check. So we're going to solve each equation. First one we have is the cube root of 3x plus 2 minus 1 equals 1. So what we're going to do is going to get the cube root isolated. So I'm going to add 1 to both sides. And when I do that, I'm going to get the cube root of 3x plus 2 equals 2. Now I got to get the cube root away. So since I know I have a cube root of 3, I'm going to raise both sides to the third power. So when I do that, the cube root and the cube are going to cancel each other out, leaving me with 3x plus 2. And then 2 cubed is going to be 8. Here, very simple. Just solve what's left over. Subtract the 2 over. So 3x equals 6. And then divide by 3. X is going to equal 2. And since I don't need to check it because it's an odd index, here is my answer. Now, if you want to check it, nothing wrong with that. It just proves that you have the correct answer. But if you trust that you did the work right, this is sufficient. Next, we have 2x minus 3 all to the 1/3 power minus 7 equals negative 4. So 1/3 is just another way of saying a cube root. So I just got to get it by itself. So just add 7 to both sides so I can clear out the root on its own side. And I'm going to get 2x minus 3 to the 1/3 equals 3. Now that I have it on its own side, I know that my index here is a 3 because it's in the denominator of this exponent. So I'm going to raise both sides to the third power. And when I do that, those cancel out, leaving me with just 2x minus 3. And then 3 cubed is 27. And from here, very easy to solve. Add the 3 over. So I get 2x equals 30. Divide by 2. X is going to equal 15. And again, because it's an odd index from the beginning, it's a 3. 15 is my solution. Last, I have the cube root of 4x minus 3 equals the cube root of 2x minus 9. Now, before I need to get the cube roots by itself, and I have 2, but each run at their own side. They're each isolated from the other. So I don't need to move anything over. I can just immediately, from the get-go, just cube both sides to get rid of it. So cube root and cube root and cube go away. So all I have is 4x minus 3 equals 2x minus 9. Now let's just go with it. I'm going to subtract the 2x over, and I'm going to get 2x minus 3 equals negative 9. I'm going to add the 3 over, 2x equals negative 6. And then I'm going to divide the 2 over, x equals negative 3. Again, I don't have to check it because of the odd index in both of them. So x equaling negative 3 is my solution to this equation.